graphical solutions of equations, or roots of equations, right? So below here we've got three equations. 3x minus x squared is equal to 0, 3x minus x squared is equal to 1, and 3x minus x squared is equal to x minus 1. Now these equations that we have here are simply quadratic equations. So these are quadratic equations. And we know for a function to be called quadratic, or for an expression to be called quadratic, this unknown must have a squared. So we have x squared, x squared, x squared. So these are quadratic equations. So there are different methods of solving quadratic equations, but we want to look at the graphical method. How can we use a graph to solve the following equations here? All right, so let's go through that, and let's start off with A. 3x minus x squared is equal to 0, and we want to solve this graphically. Now if you're going to solve an equation graphically, it means that you must have something drawn on the curve to represent this expression, and something drawn on the curve to represent this expression, something drawn on the graph. So for this, we'll have y is equal to 3x minus x squared. You just say y is equal to the whole thing, right? Y is equal to 3x minus x squared. And for this side, you will have y is equal to 0. Okay? So now, this you can easily draw, right? Table of values, and then you complete the table of values, then you come up with the points, then you draw the curve. Now you must know that there's not much need to worry about this side, because this question usually comes after you have already drawn this part, right? So this is where you will be. So this is where you are. You've already drawn the curve to represent y is equal to 3x minus x squared. So when you're now asked to solve this, you are being asked to solve it after you have already drawn this curve. So now, when you say y is equal to 3x minus x squared, you simply are understanding that this part of this equation is represented by the curve, right? This part is represented by the curve. This part here is represented by the line y is equal to 0, okay? Line y is equal to 0. Now, if you remember your lines, the line y is equal to 0 is the horizontal line that passes through 0. The horizontal line that passes through 0 is the x-axis. So this part is actually the x-axis. So now, when we get here, we're ready to use the graph now, right? Because we found something on the graph to represent this side of the equation, and we found something on the graph to represent the other side of the equation. So what do we have to do? We have to check where these two meet. So where do they meet? The curve and the x-axis, where do they meet? In other words, where does the curve cut the x-axis, right? So if we go here, we'll realize, maybe using yellow, that our curve this is the x-axis here, and that's our curve. The curve is going to cut the x-axis there and there, okay? This curve cut the x-axis at those 2 points, at 0 and at 3. So those are our solutions. our solutions are going to be x is equal to 0, right? Or x is equal to 3. You have to write both of them. X is equal to 0 and x is equal to 3. So whenever you're asked to solve something like this, where there's the function equal to 0, you simply check where the curve is going to meet with the x-axis. Where they meet, those are your solutions or those are your roots. It's a very simple way of getting your 2 marks. Let's go to the next example. Now, let's say we're now looking for the solutions or the roots of this now. 3x minus x squared is equal to 1. Now, let me remind you again, this question usually comes after you've already drawn the curve. So, you've already drawn the curve y is equal to 3x minus x squared. So, when you come to this equation here, you can tell that this side is represented by y is equal to 3x minus x squared. I'm just saying y is equal to this whole thing. Y is equal to this whole thing. When I say y is equal to the whole thing, I get this equation, which is the equation of the curve, right? So that's the curve. And again, I do the same thing. For this side, I just say y is equal to whatever is there. So there's a 1, so y is equal to 1. So now we are looking at the line y is equal to 1. That's a line. Okay, so if we come to our graph here, we don't have a line y is equal to 1 drawn here. So we have to go the extra step of drawing the line y is equal to 1. The line y is equal to 1 is simply a horizontal line that passes through 1. This is our line y is equal to 1, right? It's a horizontal line that passes through 1. So now we've identified our curve and we've identified our line y is equal to 1. The next thing is to check where they meet, right? Where does the curve cut the line y is equal to 1? Where does the curve cut the line y is equal to 1? So you can see that they cut each other there and there. So this is where they cut each other, right? If I've identified where they cut each other, I can move downwards, right, towards the x-axis to get the x values, right? What's the x value here and what's the x value there? So that there looks almost like a 0.4 and that there looks like a 2,5. Okay? So those are our roots. Those are our solutions. Our solutions are going to be x is equal to 0.4 or x is equal to 2,5. Those are our roots. Those are our solutions. It's simply where the curve is going to meet with the line y is equal to 1. Okay, so let's go to the final one. C. Now we're looking for the solutions or roots of 3x minus x squared is equal to x minus 1. So we're going to play the same game. We say y is equal to this. That's y is equal to 3x minus x squared. And we know that on the graph, that's going to be our curve, right? Y is equal to 3x minus x squared. So that's our curve. And then this side, we have y is equal to whatever is here, x minus 1, right? So that's definitely a line. But now, we do not have that line. We don't have the line y is equal to x minus 1. So what do we need to do? We need to draw the line. Now, for such a line like this, you need to have a table of values. So I hope you did these lines. You need to have a table of values, right? X and y. So you need to find corresponding values of x. So if you are drawing such a line, you pick any two values of x. So maybe I can pick 1 and 2 and then find the corresponding values of y, right? When x is equal to 1, right? Y is equal to x minus 1. So y is equal to x is 1, 1 minus 1, y is equal to 0. So y is 0 there, right? Again, when x is equal to 2, y is equal to x minus 1. So y is equal to 2 minus 1. So y is equal to 1. So we complete that. We have a 1. We have 1, 0, and 2, 1. Those are the 2 points that this line passes through. 1, 0, and 2, 1. So let's just mark those 2 points on the graph. 1, 0, and 2, 1. So we have 1, 0. This is the first point here. And then we have 2, 1. That's the second point there. Once we've done that, we can now draw our line. Our line passes through those 2 points. So we draw a straight line that passes through those two points. This is our line y is equal to x minus 1. Line y is equal to x minus 1. Let me just make that clear. Minus 1. Okay. So now we have the curve, and then we have our line y is equal to x minus 1. Our job now is to find where they meet, right? We want to find out, where do these two meet? Where does the curve and the line, where do they meet? Where do they cut each other, right? So if I go back there, I'll realize that they cut each other here and there. So those are the 2 points where the curve and the line cut each other. Once I've done that, I need to find the x values at those points. So I move towards the x-axis with straight lines. You'll be using your ruler to get this first point here, and then come down this side to get the other point there. So this first point looks like a minus 0.4, and this point here looks something like a 2.3, right? So I have a minus 0.4 and I have a 2.3. Again, these are my solutions. I've solved the equation, right? X is equal to minus 0.4, or x is equal to 2.3. So these are my solutions. These are my roots. You're simply having a curve and a line, and you are checking where they meet.